Let's look at solving exponential equations. There are a couple different ways you need to solve exponential equations, and it depends on how the equations are really set up. The first way that we want to solve them is if the equations can be written where both sides can have the same base. If that is the case, then what we are going to do is just rewrite each side so that they have the same base. So if I have here 2 to the x, the base on that would be 2 equals 16. Look and see on these. Can I have 16 be written as the same base of 2 using exponents? So we would go 2 to the x equals 2 to the 4th. Now if their bases are the same and they equal each other, then their powers must also be equal to each other. So then we get x equals 4. A little bit harder one is sometimes the bases aren't always easy to see right away if they can be written the same or not. So let's say I have 1/3 to the x power equals 81 to the 2x plus 10. Oops, 2x plus 10, that's a 10. Alright, so we have to think, can 1/3 and 81 be written as the same base? Well, 1/3 is the same as 3 to the negative 1. And if you've forgotten that rule, go back and watch the video on exponential rules. So that would be 3 to the negative 1 to the x power. When that's the case, you multiply the power. So here we get 3 to the negative x equals 81 can be written with a base of 3. 81 is 3 to the 4th power. And then we have to the 2x plus 10. So that ends up being, we multiply the 4 through by that, that would be 3 to the 8x plus 40. Alright, now their bases are the same, so we get here negative x equals 8x plus 40. Subtract the 8x over, we get negative 9x equals 40. And divide both sides by 9, you get x equals 40 over 9 negative. So there's our answer. The next way to solve exponential equations is when both sides cannot have the same base. Now that seems a little more realistic in real life. They're not always going to be nice, pretty numbers that can be written as the same base. So let's look here. If I have 3 to the x, and we're going to just do a basic one here, equals 7. You cannot take rewrite 7 as an exponential expression where it has a base of 3. So since that is the case, what you are going to do is you're going to take the log of both sides to bring that power in front. Now, because a lot of people want your answers written as in log base 10 or log base e, which is ln, what I like to do is take the natural log of both sides, because mathematicians are lazy and they want the least amount of writing as possible. So we take the natural log of both sides. I can do that as long as I do it to both sides. Now by doing that, it allows us to bring this x power in front, and I get here ln of 3 equals ln natural log of 7. Now we just solve for x by dividing the ln of 3 on both sides. So x equals ln of 7 over ln of 3. Now there would have been less problems if you took log base 3 of both sides, because log base 3 of 3 cancels. The only problem with that is that then you can't put it into the calculator as easily as this, and it's really not much more effort. So that's why I use the natural log on both sides. Now let's say that we have a little bit harder one here. It's not wanting to work. Okay, there you go. 4 to the x equals 6 to the 2x minus 1. Alright, so we go and we take the natural log of both sides here. Let me use a different color. The natural log of both sides, and I can bring the powers out in front of that. So here we have x ln of 4 equals 2x minus 1 ln of 6. And when we go to solve this, you want to bring anything that has an x on it over to one side. So I would have x ln of 4, and I'm going to have to distribute this ln of 6 through. So I would have 2x ln of 6 minus ln of 6. Okay, so we're going to subtract this term right here over, because it has the x. So I want x on both sides, or only on the one side. So I would have x ln of 4 minus 2x ln of 6 equals negative ln of 6. Now, the rule is if you have a variable that you're solving for in two different terms, look to see if you can factor that variable out. So I am going to factor the x out. I have x ln of 4 minus 2 ln of 6 equals negative ln of 6. So because I have that, this x is being multiplied by this group, with no more x's there, we can take this right here and divide it out. So we end up with x equals negative ln of 6 over ln of 4 minus 2 ln of 6. Now, that's good for solving. There may be some simplification here, but it doesn't look like it's going to do much. You cannot cancel out these ln of 6's because of this minus sign. So now we'll just stick with this as our answer. Sometimes, if you take ln of 4 minus 2 ln of 6, you know that 2, you can take it to this to that 6, so it's ln of 4 minus ln of 36. Ln of 4 minus, minus ln of 36 is ln of 1/9. So let's look at that. Negative ln of 6 over ln of 1/9. Well, that's kind of interesting here. We can take this 1/9 and I guess we could do a couple things with it. We could say that is ln, just this right here, of 9 to the -1, and bring the negative out in front. And then what we have, I've run out of room, just something you can kind of see what would have happened, is you would end up with ln of 6 over ln of 9. So it's a lot more simplified than that, but that doesn't usually happen. So this is a pretty good answer, especially if you want to put it into your calculator. You'll get the answer from here.